Hello everybody, this is Louise. Thank you very much for joining us this morning. I shall hand you over to Steve, but before I do, just to let you know, we are recording this, so if you are lost on anything, you can certainly watch it again later in the day or tomorrow. There is a questions system, so if you've got any questions throughout, if you use the questions texting system, then I'll put the questions then to Steve. So I'll hand you over to Steve.
Hiya, I'm Steve Mace from Solwise, and what I'm hoping to do today is do a rundown, introduce a new product to our range, which is essentially an outdoor 11N bridging unit. We've had several requests. You probably know we do a lot of outdoor bridging units anyway, but certainly over the last 12 months we've had quite a few people asking for higher transmission speeds, higher transport speeds. Basically, they're not happy with the sort of 20-odd meg that you get from a typical 54 11G setup. So obviously that's led us to start looking at 11N in an outdoor environment. So finally, after a bit of hunting around, we managed to find some affordable 11N equipment for just this purpose. So now, I don't know if I'll do a brief rundown of it, what exactly 11N technology means. I'll try not to be too, whatever the expression is, too technical, but just to run down some of the tricks that 11N can do, which 11NG cannot, in order to achieve the better throughput that 11N can give you. Now, the first thing is 11N technology supports the MIMO system, which is where you have multiple transmitter and multiple receiver antenna. Keep clicking on the wrong button, sorry. There we go. Now, because it uses multiple antennas for multiple transmitters and receivers, what it can do is it can do some nifty tricks with them. Now, the first thing it can do, which is indicated by this top diagram on the right here, is called spatial multiplexing, which basically means what it does is it takes the data stream and distributes it or splits it across the available transmitters. So obviously, if you send the data stream through two transmitters, let's say A and B, then on paper it's going to go twice as fast as getting it through one transmitter. Fairly obvious. And this is some of the tricks that 11N technology uses to actually get these higher speeds. The other thing that 11N technology can do is, rather than actually using the multiple antenna approach just to give you more performance, it can actually use it in order to give you a more reliable data transmission. And the way it does that is it breaks the same stream over several different channels or several different transmitters. Obviously, each one, due to the positions of each antenna, the signal takes a slightly different direction, a slightly different route to get to the destination. It also means that it can actually lower the transmission speed on each of the transmitters to give a more reliable transmission. And this is the tricky one. You probably won't understand this one, but I'll try. What it can actually do is if you've got a signal coming out of two transmitters or two aerials, by altering the phase of the signals coming out of the two aerials, you can actually direct the signal to go in a certain direction. Now, if you understand what I'm saying, that's fine and dandy. If you don't, then, ask me a question and I'll try to explain it further. But to be honest, this sort of this beam forming or directional capability of 11N, as far as I know, I haven't heard of any 11N products which actually support that function yet. So maybe that's something for the future. But it does mean 11N equipment can actually, without you having to change the orientation of the equipment itself, it can actually steer the signal in a certain direction. Now, some of the tricks that 11N technology uses to try and increase the bandwidth, remember I mentioned at the top here, it can actually split the signal over 7 different transmitters. That's one way of increasing the bandwidth. The other thing it can do is, instead of running the normal 20 meg wide channels that you're used to seeing on 2.4 gigahertz 11G type equipment, it can actually go to 40 meg wide channels. And obviously with a commensurate increase in transmission throughput. Now, the only problem is in 2.4 gig, where as far as I know, from the top of my head, I think you've only got about 18 meg of bandwidth anyway, or maybe it's even less than that. It's 75 meg or something. And obviously, by going to a 40 meg wide channel, you've effectively destroyed over half of the 2.4 gig spectrum. Now, what that means in practice is that in 2.4 gig region, 11N is not able very often to stretch its wings and actually take advantage of a 40 meg wide channel. The reason being is if 11N is trying to work in 2.4 gig, obviously it's a very crowded spectrum anyway, the chance of being able to grab a whole 40 meg wide amount of bandwidth or channel space is extremely unlikely. But of course, that's where band B 5 gigahertz comes in, because there you've got 11 non-overlapping channels. So there's plenty of room there for 11N to stretch its wings and have a really good transmission rate. And this is one of the feelings we've got in here in Solwise, is that as far as 11M technology is concerned, in 2.4 gig, it's a bit of a lame duck. Everybody wants to use 2.4 gig because everybody's got 2.4 gig equipment, but 11N really is not going to be able to work very well at all in 2.4 gig spectrum. But once you start moving 11N into the 5 gig, where you've got shed loads of non-overlapping channels, then obviously you've got a great deal more scope for transmission rates. Now, the other tricks that 11N does to try and improve the transmission thing is it does various tricks with the way it converts the data into packets and frames. One of the tricks it does is it actually reduces the interval between the frames, or between the blocks of data. Obviously, if you can send the data faster with shorter gaps in between, then the net throughput is going to increase. The other thing it can do is it can actually aggregate the frames and the blocks of data into much larger blocks. I saw a figure that when I was writing this webinar, that apparently a typical frame of data, anything up to 60% of that packet of data is actually overhead, i.e. information that tells the system where that packet is going, what the CRC check is it, and any other information that's contained in it. So only 40% of the actual packet is the actual data you want. Now, what 11N does is, rather than sending one header per packet, it takes all those packets together and aggregates them into a huge big block of data and sends one header. In doing that, I think I read somewhere, just doing that one trick actually produces a 50% improvement on data throughput. So that's another trick that 11N uses that 11G cannot do. And the net result of all these tricks is that the theoretical data throughput, I'm not talking about this 300 meg speed that you see banded around for 11N, or I've even seen 450 meg 11N equipment talked about now from Ingenious, for example. But the actual typical throughput, the real throughput, is between 100 and 140 meg maximum. Now, you've got to compare that to 11G, where a typical 11G throughput, you're talking around about 24 meg. And so 11N far exceeds that, and certainly in our office here, just in limited testing, we've achieved speeds well over 80 to 90 meg. Okay, let's come to the product that we're talking about here. This is it, non-discrete outdoor plastic box. It looks quite big, but it's not. It's sort of about the size of, well, the size of an A5 piece of paper, I think, not much bigger than that anyway. There are two versions of it. Sorry, the product we call the MIMO Jnr. There are two versions of it. One is for the 2.4 gig band, and one is for 5 gig band B. As I say, 2.4 gig band is a bit of a lame duck. We stock it just in case anybody wants to buy it. But in a couple of months we've actually been stocking these two products. I think we've almost completely sold out of the 5 gig version, and I don't think we've sold a single of the 2.4 gig version. So obviously people are looking at this sensibly and making the right decision at the purchasing stage. There are two different versions. The 2.4 gig has a dual polarization 8 dB antenna. I'll come back to what the dual polarization means on the next slide. The 5 gig version has a 13 dB dual polarization antenna. So it's got these two antennas which act as the two separate antennas. Going back to the previous slide, that's what the MIMO wants. It wants two antennas or more for best transmission speeds. Now the interesting thing here